Humanity has long dreamed of reaching for the stars, of colonizing new worlds and expanding our presence beyond Earth. While Mars often takes center stage as the next frontier, there's another, even more intriguing candidate, Venus. Our closest planetary neighbor, Venus, holds the potential to become a second Earth, a verdant paradise sculpted from its currently hellish landscape. Terraforming, the process of transforming a hostile planet into a habitable one, might seem like science fiction, but the prospect of turning Venus into a new home for humanity is a challenge worthy of our ambition. The journey to terraform Venus will be an epic undertaking, spanning generations and demanding groundbreaking technologies. Yet the rewards are tantalizing, a planet remarkably similar in size and gravity to Earth, potentially capable of hosting a vibrant biosphere and sustaining a vast human population. Imagine cities nestled amidst rolling hills, vast oceans teeming with life, and a breathable atmosphere under a sun filtered through a carefully orchestrated veil of orbiting mirrors. This is the dream of a terraformed Venus, a vision that pushes the boundaries of our ingenuity and dares us to reach for a future where humanity becomes a multi-planet species. Before we delve into the how-to of transforming Venus, we must first understand the formidable challenges posed by its current state. Venus is often described as Earth's evil twin, and for good reason. Its surface temperature is a scorching 900 degrees Fahrenheit, hot enough to melt lead. This intense heat is caused by a runaway greenhouse effect, trapping solar radiation under a thick blanket of carbon dioxide. The atmosphere itself is a crushing 90 times denser than Earth's, composed primarily of carbon dioxide with clouds of sulfuric acid. These clouds reflect sunlight, giving Venus its high albedo and contributing to the unbearable heat. The pressure at the surface is equivalent to being 3,000 feet beneath the ocean's surface on Earth. Landing on Venus today is like descending into a pressurized furnace shrouded in toxic fumes. It's a hostile and unforgiving environment, but beneath this harsh exterior lies a planet with the potential to be reborn. Given its current state, why choose Venus over a seemingly more manageable target like Mars? The answer lies in its similarities to our home planet. Venus and Earth are remarkably alike in size and mass, meaning their gravity is nearly identical. This is crucial for human health in the long term, as prolonged exposure to low gravity like that on Mars can lead to bone density loss and other physiological problems. Moreover, Venus is closer to Earth than Mars, making travel and communication more practical. A mission to Venus could take as little as 6 months, as opposed to the year or more required to reach Mars. While the challenges of terraforming Venus are undeniably vast, they are arguably more manageable than those of Mars. Mars suffers from a weak gravity well, making it difficult to hold on to an atmosphere, and it lacks a global magnetic field to shield it from harmful solar radiation. Venus, on the other hand, has a robust magnetic field and a gravity strong enough to retain a thick atmosphere, once it's been transformed into something life-sustaining, of course. The first hurdle in terraforming Venus is taming its runaway greenhouse effect. This means tackling the immense amount of carbon dioxide in its atmosphere. One proposed method involves deploying giant orbital mirrors to reflect sunlight away from the planet, thus cooling it down. As Venus cools, the carbon dioxide in its atmosphere would begin to condense into a liquid and eventually freeze, forming dry ice glaciers on the surface. These glaciers could then be buried or chemically sequestered, effectively removing the CO2 from circulation. This process would require a sustained, large-scale engineering effort, perhaps using fleets of autonomous spacecraft to construct and maintain the necessary infrastructure. Yet, the payoff would be enormous, a cooler Venus with a less dense atmosphere paving the way for further transformation. Section 5. A planetary sunshade. While removing carbon dioxide is crucial, Venus receives far too much solar radiation to be habitable. To address this, we would need to create a planetary sunshade. This wouldn't be a single, giant structure, but rather a constellation of smaller, interconnected mirrors, strategically positioned in space to block a portion of the sun's light. This sunshade would act like a giant umbrella, reducing the amount of solar energy reaching Venus and further contributing to the cooling process. By carefully adjusting the size and position of the mirrors, we could even simulate a day-night cycle on the planet, a crucial element for Earth-like life. This orbital ballet of mirrors would require advanced robotics, materials science, and a deep understanding of orbital mechanics. But the result, a cooler, more temperate Venus, would be a testament to human ingenuity and a giant leap towards our goal. Section 6. Delivering oceans from the stars. With the temperature and atmosphere becoming more manageable, the next step would be to give Venus something it currently lacks: liquid water. Fortunately, our solar system has a surprising abundance of water ice locked away in comets, asteroids, and the moons of outer planets. One proposed method for delivering this water to Venus involves carefully redirecting icy celestial bodies like comets or water-rich asteroids so they collide with the planet. These impacts would release vast amounts of water vapor into the atmosphere, which would then condense and fall as rain, filling Venus's nascent oceans. This process, while seemingly straightforward, would require precise calculations and careful manipulation of celestial bodies, potentially using massive spacecraft or even controlled nuclear detonations. It highlights the immense scale of terraforming, a project that demands we think not in terms of years or decades, but of centuries and millennia. Section 7. Breathing life into Venus. With oceans forming and the surface temperature continuing to drop, the focus would shift towards creating a breathable atmosphere. This would involve a combination of removing remaining carbon dioxide, converting existing nitrogen into its breathable form, and introducing other essential gases. One promising avenue is the use of genetically engineered microorganisms such as cyanobacteria, which played a crucial role in oxygenating Earth's early atmosphere. These microscopic engineers could be seeded into Venus's oceans and atmosphere, where they would absorb carbon dioxide and release oxygen through photosynthesis. This biological approach to atmospheric engineering would require careful monitoring and adjustments to ensure a stable and breathable atmosphere for future inhabitants. It underscores the interconnectedness of terraforming, where each stage builds upon the previous one, creating a complex and evolving system. Section 8. Venus Reborn, a vision of paradise. The terraforming of Venus is a multi-generational project, a testament to humanity's ambition and our enduring fascination with shaping the world around us. While the challenges are immense, the potential rewards are even greater. Imagine a future where Venus, once a hellscape, is transformed into a vibrant, Earth-like paradise. Lush continents span its surface, crisscrossed by rivers and dotted with lakes. Vast oceans teem with life, reflecting a sky painted with clouds and illuminated by a familiar sun. This is the ultimate goal of terraforming Venus, to create a second home for humanity, a planet where we can thrive and continue to evolve alongside the life we introduce. It is a vision that pushes the boundaries of our current technology and understanding, but one that is within the realm of possibility if we dare to dream big and commit to the long-term vision. Compared to the challenges of colonizing Mars, terraforming Venus, while a more daunting task initially, offers a potentially more rewarding outcome. A habitable Venus would be a true second Earth, a testament to human ingenuity and a beacon of hope for the future of our species. It is a journey that will test our limits, but one that holds the promise of a brighter future among the stars.